Does a linear relation exist? Our objective, determine whether a linear relation exists between two variables. So let's remind ourselves what we already know. The linear correlation coefficient is a number between -1 and 1 inclusive, that measures the strength and direction of the relationship. And we calculate the linear correlation coefficient in StatCrunch via STAT, summary stats, correlation. All right, if we have observed a linear relation in a scatter plot, then we can test to determine if the relationship is significant. I believe I misspelled that. We'll put significant using the following test procedure. Well, we first determine the absolute value of the linear correlation coefficient. Second, we'll find the critical value in the critical values table for the given sample size, and here's the critical values table. Third, we'll compare the two numbers. If the absolute value of the correlation coefficient is greater than the critical value, we say the linear relation that exists is statistically significant. Otherwise, if it's less than the critical value, the linear relation is not statistically significant. So here is our critical values for correlation coefficient table. And let's do an example to see how this works. All right, we've worked with this example previously, but we'll do it again and review how to find this in StatCrunch. The data set in 4_1_27 represent commute time in minutes together with a well-being index score. Use the procedure outlined above the other page to determine if a linear relationship exists between the commute time and the well-being index score. Okay, well, let's first go to that data set. And there it is, again, 4_1_27. Okay, we're going to find that critical value again, and we do that with STAT, summary stats, correlation. So STAT, summary stats, correlation, here we are. And we need to select both columns in order to have it find a linear relation between the two. Okay, and we'll compute. I think we'll compute. Oh yes, I hit it twice. And we see that there is the linear, the correlation coefficient, -0.981 to 3 decimal places. Okay, so give me a minute to let me get a minute here too. Okay, so we determined the absolute values. So we came up with R is equal to -0.981. The absolute value of R is equal to the absolute value of -0.981, which of course is +0.981. Okay, now we're going to find the critical value for the sample size. Well, the sample size was 7. You can go back and take a look at that, but we had 7 points. So let's note that. Sample size equals 7, and that leads to a critical value of, well, here's our critical values table. Our sample size was 7, so our critical value is 0.754. Okay, 0.754. And we want to compare those two. Okay, 0.981, which is R, is greater than 0.754, which is the critical value. Okay, therefore, the linear relationship is statistically significant. The linear relation is statistically, statistics, S-T-A-T-I-S-T, T-I-C-A-L, I hope I spelled that correctly, I don't think I did, is statistically significant. And there you have it.